So in IPv4, you have 32 bits, 4 octets, back, and you have 8 bits per octet. Dotted decimal is how it's usually written out. You might be familiar with it if you've ever seen like your IP address at home. It might be something like this. Along those lines, that's dotted decimal. That's how it's represented. Each of these octets are separated by a period, and when you're trying to do the math on figuring out what these numbers mean, you can convert them from dotted decimal to binary and back and forth. Binary, of course, being ones and zeros. So if we're going to convert this dotted decimal into a binary, it's as simple as looking at each octet and figuring out what those means in 1 and zeros. But to figure that out, you have to start with this number: 1, 2, 8, 6, 4, 3, 2, 16, 8, 4, 2, 1. Each of these numbers represents one bit of information within that octet, because each of them are 8 bits. So if we were to take 192, for example, you can think of all these as zeros. And if all of these are zeros, then it's going to equal 0. But if we have a 1 here and a 1 here, 128 plus 64 is going to equal 192, and the rest of this will be 0. So just from that, we can tell that the very first octet right here is going to be 1, 1, 0, 0, 0, 0, 0, 0. Now we're going to separate it by a period. 168, that's going to be 128. It's not going to be 64 because that'd be too big. It's going to be 32 because that would bring us up to 160. It's going to be 0, and then it's going to be a 1 because 16 would be too big, but 8's just right. So from that, we have 1, 0, 1, 0, 1. It's 4 right there, so 0, 0, 0, and then dot. All zeros would be 0 again, so that's just another 0. And at the very last one, our very last octet, we have 10, which would be 8 plus 2. So the last one you'd have 0, 0, 0, 0, 1, 0, 1, 0. Whoops. 0, 0. Let me erase that real quick. So you have 0, 0, 0, 0, 1, 0, 1, 0. So that's how you convert this IP address right here into binary. So that's how you convert dotted decimal to binary. That's what the binary looks for all of them. Conversely, you can convert it from binary to dotted decimal just by looking at what all these match up. Because as we know already, the very first bit in this octet of 8 bits is going to be 128. The next one's going to be 64, and it divides by 2 as it keeps going down until it hits 1. So just by looking at this, since there's only 2 1s in the very first 2 bits of the 8 octet, or the 8-bit octet, we know that it's 192 because 128 and 64 add up to 192. It's important to know this because network bits and host bits in the term of a subnet is separated based off of when these 1s stop and when only 0 starts, which I'll go into a later video, but this is a basic explanation of dotted decimal and binary and conversion back and forth between for IPv4 specifically, which is very dissimilar from IPv6, which would look something like this. That, for example, I believe is the link local address for IPv6, which is in a hexadecimal format using numbers and letters.